We want to find the solution to the differential equation dy dx equals xy, where y is greater than 0, given that y equals 2 when x equals 0, and giving our answer in the form y equals f of x. So we have dy dx is equal to xy, and we want to separate the variables. The y can come underneath here, and the dx up here, giving us dy over y is x dx. And of course, once separated, we have to write integral signs around both sides. This becomes log y. We don't need a modulus sign because we're told that y is greater than 0. If we integrate x, we get x squared over 2, which can be written as a half x squared, and of course we need the constant. We can evaluate this constant because we're told y is 2 when x is 0. Substituting in, we get log 2 equals c. Remember, x is 0, so a half x squared disappears. We can now write that log y is equal to a half x squared plus log 2. But of course we must give our answer in the form y equals f of x. So we're going to have to manipulate. Bring the log 2 over with the log y, and then use our knowledge of log laws here to write log y over 2 is equal to a half times x squared. We want to write the answer in the form y equals f of x, so we need to remove the log here. In order to do this, take the exponential function of both sides. Exponential and log are inverse functions, so the left-hand side just becomes y over 2. For the right-hand side, we get e to the power of a half x squared. Now all we need to do is multiply both sides by 2, so we get y equals 2 e to the half x squared.